I'm Paul Gross. I'm an extension educator at Michigan State University. I'm at the North Central Research Station, west of St. John's, and I'm talking about cover crops and soil health. And I'm standing here in the middle of a clover that was frost seeded into winter wheat. A real nice stand. And what we have here is an opportunity to look and think and talk about the importance of covers in your cropping system. And when you think of your soil, you need to think of your soil as a factory. And a factory gets its energy, the soil factory gets its energy from the sun. So I think it's important that farmers always think about how many months a year they have live roots in their soil. And you should keep track of that, like you keep track of your fuel use and a lot of your inputs. And I think we can have a good example here of the importance of live roots. And if you think of your soil as a factory, and you think of energy for your factory as free sunlight through photosynthesis, and the energy that your factory runs on is carbon. And the workers in your factory are actually the microbial communities in the soil. And when we start to dig out some of these live roots, I think we really have an opportunity to look at our rooting system of this particular cover crop. We can look at others, but I think what's really important when we talk about having a functioning soil system is looking at our roots and looking at the rhizosphere effect around the roots. When we start to see these roots, when we have live roots in the soil, we have plants that are collecting sun through photosynthesis. They're moving those carbohydrates and sugars down into the roots, and they're sharing that through root exudates with those microbes, those microbial communities. Those microbial communities around them roots, which is the rhizosphere effect, actually are exchanging nutrients with the plant roots. They're bringing those nutrients to the plant, and the plant is in turn giving them the sugars in order for them to survive and build their bodies and multiply. And when we do that, we're starting to put that carbon back into that soil. When we start to build the organic matter, build that organic material that drives our soil. And what's really fun and interesting to do is look and see around the live roots, you start to see those aggregates beginning to build. And those aggregates beginning to build are what makes that aggregation. And it actually makes the porosity that allows the soil to take up the water and hold the water. What's really interesting is when I look at the roots on this red clover, and this is red clover that was frost seeded in March at approximately 10 to 12 pounds to the acre. So we got a really good stand. And we got 6 inches of roots here. We've got, you can see white nodules, so see the nodulation that's occurring. And I think what's really interesting for farmers to do in land managers, I always say, does your soil pass the smell test? And I think it really, if you smell that soil, that good, healthy, rich soil, it has that real earthy smell to it. And I think as farmers and as land managers, we know what that smells like. And when you smell the soils that have the covers in, the good aggregation, when we dug this up, there's multiple worms that we saw in this particular soil. So having live roots, having that sunlight being captured, be putting into the soil is one of the steps that farmers can do and think about in managing soil for improving soil health, and cover crops are the way to do it. This is the red clover. It's more of a tap-rooted type of plant. I do have some oats on the same site, and you can see the difference between the rooting systems. Here's another example of the rhizosphere effect on a grass plant. You see the real fibrous roots, and it's really, what's really interesting is the grass roots. As you can get closer to these, you can see the soil particles wrapped very tightly all the way around the root. So you really get a good view of that rhizosphere effect that we talk about, and we think that is really important part of building soil health through moving that carbon from the air through photosynthesis into the root profile, feed the microbial communities, and build soil health.